The name of this project is COVID-19 Data Visualization using Python. And welcome to the notebook. Let's go through the project structure, which includes total of 4 tasks. The first task is of introduction to understanding the purpose of the project, the data set that will be used, and questions that will be answered with analysis. Second task is of visualizing global spread of COVID-19 from first day of the pandemic using PLOTLY map to visualize global spread of the COVID-19 from the first day of the pandemic. The third task is of visualizing how intensive the COVID-19 transmission has been in each country using a bar chart to compare different countries in terms of how massive the spread of the virus has been there. The fourth and the last task is of COVID-19 spread before and after lockdown in Italy and visualizing the impact of the national lockdown in Italy on spread of the virus. So our task 1 is of importing the modules. The first one we import is pandas, followed by numpy, followed by plotly.express as px and matplotlib.pyplot as plt. This matplotlib.pyplot as plt is used for visualization, and numpy is used for dealing with the arrays, pandas is used for dealing with the data frames. So what exactly this plotly.express is? The Plotly Python library is an interactive open source plotting library that supports over 40 unique chart types covering a wide range of statistical, financial, geographic, scientific, and three-dimensional use cases. The task 1.1 is of loading the dataset. The very first image you see is the image of the website from where I have loaded the data, and the very next image is of the raw data. This is exactly how the raw data looks like, and it is separated by commas, so it's comma separate values, so therefore the CSV file. And I have not downloaded this file in my local computer. Rather, what I will do is, in a variable dataset URL, I will store the URL of this dataset from the website, and then I will create a new data frame called df using pandas.read CSV. I will pass the location of that URL, and our data frame df will get formed. In task 1.2, what exactly I'm doing is I'm just viewing initial few rows of the data frame created, and also last few rows of the data frame I have created. Then I also check the shape of the data frame I have created, and it's 47,752 rows and 5 columns. And the most basic question which arises here, why the parentheses are absent after the shape, as we have parentheses for head and tail. The reason behind that, I have written it down, and let me read that out for you. When you call the data.head, you are actually calling the method head self on the object data. However, when you write data.shape, you are actually referencing the public attribute, not method, attribute of the object data. It is good to keep in mind that there is a distinct difference between the methods and the attributes. So task 2.1, in this, let's do some pre-processing. We select the confirmed column, right, this one. We select this column and we put a condition as greater than 0. It means if confirmed cases are greater than 0, only those rows will be selected. So at the end, we are able to manipulate our data frame, and when we display the manipulated data frame, you can see in the output the minimum number of confirmed cases now for each country will be 1 and not 0. If at all you want to see data related to a particular country, let's say for example Italy, then you just have to go inside the data frame, select the column where Italy will be present, that is country, and you match it with Italy. If it matches with Italy, then the data frame formed will be regarding Italy itself, and then you can view the data frame as well. Now let's see the global spread of the COVID-19. In figure variable, I'm actually using from plotly px.horoplat, in which I have to pass as arguments these. The first one will be the data frame I want to deal with. Then I'm actually interested in the locations as country. Then the location mode will be the country names, and the color is equal to confirmed, which means for the confirmed column different values will have the different color range, and animation frame is equal to date, like this is for the seeking bar, which you will see in the output. And if at all you want to update the layout created previously, you can just use dot update layout and give the title, as we did not give the title in the previous argument, the global spread of the COVID-19. And to display the figure created, ultimately we just have to write the name of the figure, and in the output you can see the visuals that have been created. You can see like this is the world map, and you can see wherever the confirmed cases, like in this area, the China area, for this particular date, and the country is China. The confirmed cases are 77.241k, and this is the scale on the right extreme, the confirmed cases scale. And this is the date in the shaking bar, as I said in the previous during the writing of the code. I can just play this, and you can see how the transition of the confirmed cases and how the confirmed cases took gradual increase for each country. Let me play this one. Now you can see, just visualize how the confirmed cases increased for each country. Right now at around 70 to 80k it's yellow, and from 0 to 10k it's dark blue. Okay, let me just seek this far. Okay, this is the seeking bar for the dates. You can see, let's check out for India from date, let's say it's around 2020, 8th month, and the day is 22. I think from here it starts changing drastically for India. Let me explain that. Okay, now you can see change of the color in India as well. Slowly is getting towards 6 million confirmed cases. Yes, you can cross check from the scale, the dynamic scale for the confirmed cases from the right. The task 2.2 is similar to task 2.1. Just this time we will have different colors for the deaths column in our data frame, and you can see the transition and the variation, how the number of deaths increased in the respective countries in the world map right here in the output. And you also have the respective death dynamic scale for getting the idea which country has more deaths and which country has less. You can play this one as well, and you can see how the transition has happened, how the number of deaths increased with respect to the dates in the seeking bar for all the countries. In task 3.1, let's visualize how intensive the COVID-19 transmission has been in each of the country. Let's take an example. Let's go with China, and we have created a data frame for China itself, df underscore China, and then getting inside the data frame, we select the column country and we compare it with the string China, so that in our newly formed data frame we have country only China in the country column, and then we view our newly formed data frame and we see that all the countries will be China and rest of the countries will be eliminated. Now let's go ahead and select the columns we need. Then we can have the desired columns as well, and we can drop rest of the columns. Let's go with date and confirmed column of the newly formed data frame, and I have selected the columns by passing this list of two columns. And then when we view the column using dot head, you can see the date and the confirmed column has been included, and rest of the columns we don't need right here has been excluded. If at all you want to calculate how the infection rate increases for respective countries, or in our case here we have taken the example of China. So let's proceed and see how the infection rate has grown for the country China. So to calculate the infection rate for China, what we have to do using the data frame for China, which we previously created and manipulated, we just have to select the confirmed column, and we have to use dot def. So we get the first derivation, and using the first derivation, what we actually get as a result is the infection rate. So we store it in a new column for the data frame China, in the infection rate, and then when we display our data frame that is manipulated, we see a new column, infection rate, has been created with date and confirmed, and the first row will have infection rate uh, as a missing value or a non value. You can say not a number value, because there is no element present to get a derivative for the first row. But from the second row you will have certain values for the infection rate, and you can see how gradually it varies. The infection rate varies for the first few rows. At least the infection rate has, you can say, drastically increased. Now, if at all you want to see how the confirmed cases varied with time, and how the infection rate varied with time, then we have to use from plotly px.line, and arguments we have to pass. The first one is the data frame, then x-axis obviously the date, and y-axis the column we want to see how it varied with respect to time, which is confirmed here. So now in the output you can see how the graph varies. You can see how the confirmed cases increased with respect to time. Okay. Now similarly, we will see how the rate of infection increased or varied, to be more precise, with respect to time. So similarly, we will be passing the data frame we want to deal with. Then the x-axis will have the date, and y-axis will have the infection rate column. Now in the output, you can see how the infection rate varied with respect to time. This is the highest point, which is the date is, what it means is on 13th February 2020, the infection rate was the highest, which is 15.136 thousand. And also, if you want to cross check, you can just use the data frame df underscore China and write the column, and you can use the dot max to check the maximum infection rate, and you can see it's 15,136, which we viewed on our graph previously. Task 3.2, it says let's calculate the maximum infection rate for all the countries. So before we proceed and calculate the maximum infection rate for all the different countries, we will just check out what our original data frame was. Using df.head, we see initial views of our original data frame. Then we select country column from the data frame df and store it in countries, and then we display the countries, and you can see the country column is displayed. Now the problem is it is not in the form of list. So in the very next cell, what we do is we typecast it to the list format using the keyword list, and then we display it. Now in the output you can see, since it starts with a square bracket, this is probably a list. The another problem which arises here is like the country names are repeated many times, so we want unique names in the list. So what we do, to the columns country which is selected from the data frame df, we pass dot unique function, and you can see when we display the countries now, after manipulation, all the unique countries names are there in the list, and they are not repeated. So let's go ahead and do the most important part of this task. In this cell, what we do first is we define an empty list, maximum infection rates. In this, we will append maximum infection rates for different countries. For that, first of all, we have to browse through, or you can say traverse through different countries. So for loop will be used, and the very next line of code is the most important part of this cell. To understand this, I have divided it into four, or you can say split it into four different steps to understand it in a more vivid way. And I have written all those four steps and displayed outputs for respective steps in the very next cell. So let's go to the next cell and then we will come back to this cell. So in the next cell, what we first have to do is define a desired country. Let's go with India, my country. And the very next is the first step. First step, what we do is we create a selective data frame in which we have India in the country column only and rest of the countries will be excluded. So in the output you can see only India is selected in the country column and rest of the countries are excluded. In the very next step, which is step 2, we just have to do little addition to the step 1. This is the step 1. The selected part is step 1. This actually represents the previously manipulated, or you can say a newly formed data frame. This is actually a data frame which you see in the output right here. And to this, if you add in square brackets the confirmed column, what actually happens is, you can see in the second output, the confirm column is selected and displayed right here, this one. Then let's move to the third task. In the third step, not task, in the third step, we do some more addition to the previous step, which is step 2. This is till here we know the confirm column is selected. Now using to this the dot differentiation, what we are able to do is we are able to calculate the infection rate for the country India. Now the output is displayed. You can see in this part you can see the infection rate for the country India has been displayed. The first row will have obviously the missing value, and then the gradual increase can be observed, and later on the ups and downs and the constant variation can also be observed. Then in the fourth uh, step, again some more addition to the previous step, which is step 3. Till here we have the step 3, and till here what output we have is the uh, infection rate has been displayed till here. Now among those infection rates for the country India, what is the maximum infection rate? So we have to use dot max function, and you can see output I have displayed for the step 4 as well. The maximum infection rate among all the infection rates from the beginning of the coronavirus in India is 97,894. Now let's go back to our previous cell. Yeah, right here. So this line of code is understood by us in the very next cell already. Now what we have to do, we simply have to print the name of the country and the maximum infection rate that country has. So that is printed and then also appended to the list we have created using dot append function, and then we also print the created list and to check what values have been uploaded in this. So let's check. So maximum infection rate for different countries you can observe in the output. So we can also observe for India right here. The maximum infection rate of India is 97,894.0, and you can also at last see the list which gets printed. You can see the list of the maximum infection rate for all the countries has been displayed right here. So in this task 3.3, we will actually visualize whatever we have formed in the previous cells. First of all, to create a new data frame, we will use pandas and dot data frame obviously. Then we form a new column inside it called country and load all the country values in it. Then we form yet another new column, maximum infection rate, and we load all the maximum infection rate values in it. Then we display the data frame, and in the output you can see with country column and maximum infection rate, the new data frame has been formed. Let's go ahead. Now let's plot the bar chart of the maximum infection rate of each country, and to do so we will use plotly, therefore px, and then dot bar for plotting the bar plot. Then as argument, what all we have to pass is the first one is dfmir, the data frame we have created, or you can say the data frame we want to deal with. Then x axis will be the country column and y axis will be the maximum infection rate, and this color is equal to country. It means for different countries different color should be displayed in the output. And we also want to give the title, so title is given as global maximum infection rate. Now when we press shift enter, we see in the output the bar chart. In this you can see with different colors different countries represented, and the maximum infection rate for different countries is displayed in form of bar chart. Let's say for this one, for Brazil, the country is Brazil, and the maximum infection rate is 69.074K. Pretty huge. And the maximum is for, it's India probably, I think. Yeah, the country is India, and the maximum infection rate is the highest, 97.894K. Then this is the second highest. This is country US, and the maximum infection rate is 77.373K. And you can also observe, like for some countries, you actually it's very difficult to visualize their data, and all the countries are not displayed even. So let's go ahead and solve this problem. To solve this problem, we just have to add one more argument, which is log underscore y is equal to true, which means it will just do the task of scaling and it will solve the problem occurred in our previous cell. And in the output you can see, now you can visualize for all the countries. Now earlier they were very pretty small and only few countries were you can hover the mouse over and view the data. Now for all the countries you can hover the mouse and view the data for them. So let's go ahead and do our fourth and the final task, which is seeing how the national lockdowns impacts COVID-19 transmission in Italy. COVID-19 pandemic lockdown in Italy on 9th March 2020, the government of Italy under the Prime Minister Conte imposed a national quarantine, restricting the movement of the population except for necessity work and health circumstances in response to the growing pandemic of COVID-19 in the country. So I have mentioned the start date of the lockdown, and a month later date has also been mentioned. Then we view the original data frame DF and it's unaffected still. You can view in the output. Then the next thing in the next cell what we do, let's get the data related to Italy. We are dealing with the country Italy, so we will form a new data frame. We will form a selective data frame in which the country column will only have the country name as Italy. So in the output you can cross check the new form data frame, and in the output you see the country column will only have the Italy country. Now let's calculate the infection rate in Italy. To calculate the infection rate, you have to write this line of code. And to store all the infection rates of the country Italy, we form a new column in the data frame df Italy, and it's called the infection rate. And in this, all the infection rate values are stored, and you can view the newly formed, or you can say manipulated data frame now. And now you can see one more column called infection rate has been included in the data frame df Italy. Now what we observe in this output is this value of infection rate in the very first row of the data frame df Italy is negative, and it should not have been the case. Rather a nan or a missing value should have been there. So to deal with this, I would just drop this row and then proceed. So in the next cell, I have dropped the first row by using the condition that the infection value should be greater than or equal to 0. The infection rate value should be greater than or equal to 0. So in the output when displayed, you can see the column has been removed and it starts with 0 now, which is left for our calculations. Now let's visualize what we have created. We will store it in the variable figure, and using plotly px.line, we pass the data frame we want to deal with. Then x-axis obviously is the date because we want to see with respect to time, the variations with respect to time. Variations in what? Variations in the infection rate, which I have passed as y axis. And you can optionally give the title as well, like before and after lockdown. Now in the output you can see the graph that has got formed. You can see how the infection rate has varied with time. And then the very next task is using the attribute add shape. In this you have to pass parameters like what kind of diagram you want. We want a line type, so I have written line. And then we have to mention, since it's line, then 2 points have to be mentioned. So x0 y0 is the first point which is mentioned, and x1 and y1 are the is the second point which I mentioned right now. And I have to type cursor to dictionary. All these parameters will be converted into the dictionary form. And to decide the color of the line, you can use dictionary again, and color will be is equal to red, and width you can decide, let it be 2. So in the output you can see the title before and after lockdown in Italy, and then a red line is formed as we have mentioned in the parameters. Similarly, here in the output you can observe that no annotation is there, and annotations are absent. So you can also write code lines for giving the annotations. So for that you have to use the attribute add annotation, and then obviously you have to change all the parameters in form of dictionary. Therefore the typecasting using the keyword dict, and the parameters passed will be x and y, and the text you want to write for that annotation. So x and y decides where the annotation is, and the text is the text which decides what annotation it is. So the text is starting date of the lockdown, and you can see in the output the annotation has been placed, which is starting date of the lockdown. Similarly, you can do for the other end as well, and you can form other line for the end date as well, and the task will be complete.